We had a problem where a rocket consists of a right circular of height 20 surrounded by a cone whose height and diameter are equal and whose radius is the same of the cylindrical section. And the question that we're going to solve is what should this radius be rounded to 2 decimal points if the total volume is 500 times p over 3.
The only data that we know is that the height of the cylinder is 20 and that the height of the cone is 2 times radius.
And we're going to solve it. We have three possible answers: x1 that is minus 29.72, the x2 2.76, and x3 that is minus 3.05. We're looking for the radius, so we cannot have a negative radius, so the answer is x2 2.76. We have the volume of the cone and of the cylinder, and we need to put it together and make it equal to the total volume that we already have, and then start isolating in order to have the radius. So we started here, and we have 2 times pi times radius to the cube over 3 plus pi times radius to the square times 20 equals 500 pi over 3. And then we have to take away the 3, so we eliminate it, and the pi in here. And we're gonna have 2r squared to the cube plus 60 r to the square equals 500. Then we have this, and we're going to look for the common factor, that is radius to the square. So radius to the square times 2r times 60 equals 500.
So this is how we made our flow chart. We have our figure, which is a rocket. We have the cylinder and the cone. We know that the height of the cylinder is 20 and we don't have the radius. So we need to know both of the formulas to get the cylinder and the cone. So we know that to get the formula of a cone, it's p times r squared times height over 3. And to get the volume of the cylinder, p times r squared times the height. So we have our two formulas, then we have to separate them and we have to equal them to the total volume. Well, let's say this goes from here, then to here, and to here. So we have our formula, and then what we need to do is we solve all the following steps as my partner explained in the other video. And then you have the result. There are three results, I'm sorry. Two negatives and one positive, and we achieved our result, which was 2.76. So we're going to graph our problem. We have y, we have our x. We know that our y-intercept is 0, 500. So we know it has a degree 3 because this layer on is going to be multiplied, and we know we're going to have 3 zeros, 3 possible solutions. So our first zero is going to be approximately here. Then we have our second, which is right here, and the third almost over here. So we know it's an odd degree, it's also positive. So we know it's gonna end like this and not like this. So it crosses the y-intercept and it goes all the way. And if we want to know the end behavior of our graph, we know that as x goes to negative infinity, y goes to negative infinity also. And as x goes to positive infinity, y goes to positive infinity. That's it.
To solve the problem correctly, we substituted the values they gave us to find the radius of the cone. These type of problems are really useful for people who are studying careers such as engineering. Why? Because if you want to know the area of, I don't know, a house, you need to have these formulas to find a volume and everything you need.